It's Katie Kimberling with TutorPUG, and I'm going to do a few examples of difficult derivatives. So these could be incorporating any of the different rules you're responsible for: product rule, chain rule, any of the natural log rules, or the power rule. Anything's fair game. So I would consider these difficult, and maybe you want to consider them test level difficulty. So the first thing we have is a function in the numerator, 3x squared plus e to the 2x. In the denominator, cube root of the quantity, natural log 4x minus 3x to the pi. So that is a huge mess, and we remember that right now at this stage of the game, we do not have the availability of deriving the top by itself and then deriving the bottom by itself separately and saying, yay, I'm done, go home. It just doesn't work that way in math. My first step is going to be to pre-calculus this. I will bring the entire denominator up, and then I can use the product rule. The way I do that is we have to remember two rules from pre-calculus. One of the rules is when I bring something out of the denominator, I bring the whole thing up and the exponent becomes negative. The other rule I'm going to use in conjunction with that is if I have the heart root of something to the smiley face, I'm just picking symbols, that can be rewritten in order to kill the radical as what's underneath the radical sign raised to the fraction exponent smiley face over heart. This floats to the top. That's the denominator of the fraction. So that allows me to, first of all, rewrite this without the radical. I can rewrite that entire statement as blah, 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 raised to the 1/3, because that did not have an exponent on it as a quantity, so I can call that exponent 1. And I was taking the cube root. So the invisible exponent of 1 on that whole statement floats to the top, the cube root floats to the bottom. Now I can bring that up to the top and change the sign on that exponent. So that gives 3x squared plus e to the 2x. And I'm going to bring this whole thing up. Natural log 4x minus 3x to the pi to the negative 1/3. I have not done any calculus. I have not taken a derivative. I have simply put this into a form where I am now able to apply some of my derivative rules. So I've rewritten, here's what I have to derive. And if I sort of stand back and give it a look, I have two main chunks of information that are being multiplied together. So that means I have to do the product rule. And the product rule says we are going to, the way I do it, you can interchange them, but the way I do it is I write the first one as is, and I derive the second one, and then I write the second one as is, and I derive the first one. The product rule is everybody gets to stay the same, and everybody gets to be derived, but everybody has to wait their turn while the other guy does his thing. And we always have a plus sign in the middle, so that's why these two statements could be interchanged. You could derive the first and keep the second one the same first, and then derive the second, keep the first the same. It doesn't matter. When I'm ready to derive the second, since that has an inner portion and an outer portion, I will have to use the chain rule when it's his turn to get derived. So my chain rule says if you start out with an inner and an outer, when you derive it, the inner stays the same to begin with while the outer drops and flops, and then you multiply by the derivative of the inner. it's another wait your turn. The inner's going to just sit there and be the same and hold on tight for a second while the outer portion derives. And then the outer's like, okay, I'm done, I'm good, I'm just going to sit over here and not do anything while the inner gets derived. So this is probably going to get really long. I have an 8-foot whiteboard. Give yourself some space. So I'm going to call this first portion chunk number 1 and this second portion chunk number 2. So I'm ready to start out by the product rule because I have two big things multiplied together, and when it is time for this to get derived, I will use the chain rule. Here we go. Derivative is, the first one stays the same, recopy. Second one, it's your turn to get derived. I'm ready to derive the second. I'm going to use the chain rule. So when I use the chain rule, the inner portion gets recopied and sits there as is while the outer is going to drop and flop. So natural log for x minus 3x to the pi, there's my inner staying the same. This guy is going to drop down in front and then flop back 1. Negative 1/3. Negative 1/3 minus 1 is negative 4/3. So that is just this part of the chain rule. Now I'm going to multiply by the derivative of the inner. So when I derive the inner portion, I have to use some special rules. I have the natural log of blah. So when I derive that, the blah goes in the bottom. The blah is just the argument. And the derivative of the blah goes in the top. Now it's your turn. That's a variable raised to a number, so that's a standard drop and flop, which means the pi is going to fall down, it's going to drop down, and flop back 1. And that will leave me 3 pi x to the pi minus 1. All right, so following product rule, there's 1, there's the derivative of the second. I'm halfway done. Now I'm ready to add the second original times the derivative of the first. So I'll drop down here. Now it's the second's turn to stay the same. Natural log for x minus 3x to the pi to the negative 1/3. That's the second one. And now I'm ready to derive the first portion. Derivative of 3x squared, straight drop and flop. That gives me 6x. Derivative of e to the 2x, that's an e to the blah. So that derivative says e to the 2x, I recopy it, times the derivative of the exponent, or the blah, which is 2. 1 d2 plus 2 d1. So let's continue on. One of the biggest questions that I get is, how do I know if I'm going to use the product rule first or the chain rule first? And the answer is, you don't get to decide. The problem will tell you. So I've taken the exact same components of the first problem I did. I've changed them up just enough so that I've taken the cube root of the product of those two items. So that means this whole thing, all of it, is being raised to the 1/3. So in this example, I have to do chain rule first, and then when I'm ready to derive the inside, I use product rule. So the first thing I'll do is, I'm still just pre-calculusing it. I'm going to rewrite this whole thing to the 1/3. I can take rid of that radical, I can get rid of that radical, and just write it to the 1/3. So now I'm ready to do the chain rule because I have an inner. It's a big inner, but I have an inner all kinds of gobbledygook raised to an outer. When I'm ready to derive the inner, I will use product rule. The first guy times the derivative of the second plus the second guy times the derivative of the first. So here we go. Again, leave yourself some room. I'm going to recopy the inner so I'm not tempted to mess with it yet. 3x squared plus e to the 2x times natural log 4x minus 3x to the pi. And on the outer part, the 1/3 drops down. And 1/3 minus 1 is negative 2/3. That's the first part of the chain rule. Now I'm ready to multiply that by the derivative of the inside components. And the derivative of the inside components, there's my first one, and there's my second one. So product rule says I got to do 1d2 plus 2d1. So pretend that I'm doing this on one line. I'm just going to start down here because it's going to be so long. The first one, as is, times the derivative of the second, derivative of a natural log of blah, blah in the bottom, derivative of blah in top, variable to a number is a drop and flop. So there's the first guy waiting his turn while the second one gets derived. Plus, now the second one waits his turn, and the first one gets derived. And all of this, my arms aren't long enough, all of this is the derivative of the inner. So the whole thing is being multiplied by that. So all of it needs to go into big brackets. So starting here, here, all of that is the proper derivative of this. Here's one more that is very fair game. It's sort of a chain within a chain. And what we have is the natural log of the natural log of a number to the blah. So try to train your eye to back up off of these. Look at it. Try to see the forest and not the trees. And this is, at the very biggest structure of it, the natural log of a blah. So when we derive the natural log of a blah, we put the blah in the bottom, and then we derive that and put it in the top. Therefore, I am taking the natural log of that blah. So I'm going to put that blah in the bottom. Now, this guy, this thing just right here, this is all I have to focus on, this is going to get derived and put in the top. So I'm ready to derive this, and that's the natural log of a blah. I'm going to put the derivative of that in the top. So when I derive it, natural log blah says I put the blah in the bottom of a fraction, and I derive that and put it in the top. So now I'm ready to derive this guy, and that becomes recopy times the natural log of the base times the derivative of the blah. Now, it's not lovely. I have a fraction, on a fraction I have a compound fraction. It could be simplified. You do not need to simplify these. You can leave these as they are for now. So I did my basic structure. I took the blah and put it in the bottom. And then when I derived the blah and put it in the top, that said, oh, okay, up here, I'm making a derivative, so I have a natural log of something, so I got to have a fraction skeleton. Blah in the bottom, derivative of the blah in the top. Happy mathing!